So we spent the last lesson introducing this normal curve, talking about how it is formed and what it means. And we also spent the last part of lesson 14 calculating probabilities from the area under the curve. And we've seen 3 ways we can do that: StatCrunch, calculator, and the table. In this lesson, we're going to look at more examples of calculating those probabilities, but instead of starting with z-scores, we'll be starting with x values. So what I mean by that is, let's say that we have some variable that is randomly distributed that has a mean of 500 and a standard deviation of 100. And let's say that we want to know the probability that a score will be less than 600. We can find that probability by finding the area under the normal curve. So if we could find the area of this region that's shaded in blue here, then I would know the probability that x is less than 600. But the problem is, in lesson 14, when we did questions like this, we did not find the probability that x was less than 600 when the mean is 500 and the standard deviation is 100. We only know how to find those areas for the standard normal curve, which is the curve where the mean is 0 and the standard deviation is 1. So I added in here, but we need the standard normal curve. And remember, the standard normal curve is the curve where mu is 0 and sigma is 1. So let's consider this issue. We have a normal curve with a mu of 500 and a sigma of 100. That's what we started off with. We have the value of say we're interested in knowing what's going on at 600, to the left of 600, the question that was posed up here. Well, 600 is 1 standard deviation above the mean, because I can see the standard deviation is 100. So if I move 100 units to the right, 600 is the value of x. That's 1 standard deviation above the mean. Now, let's consider the standard normal curve. And we know in the standard normal curve, mu is 0 and sigma is 1. So in the standard normal curve, that looks more like this one down here, where the mu is 0 and our sigma is 1 here. The z value, they're called z values in the standard normal curve. The random variable for the standard normal distribution is a z-score. The z value that is 1 standard deviation above the mean is just z is equal to 1. So what we're seeing here is in the curve with x values, these are x values, like raw scores, actual data. These are z-scores, standardized scores. And what we're seeing here is that an x value of 600 corresponds to a z-score of 1. Because if I move 1 standard deviation up in the x values, I'm at 600. We just saw that up here. And if I move 1 standard deviation up in the normal score, we are at 1. So since those two correspond, the area to the left of 600 is the same thing as the area to the left of 1 in the standard normal curve. When we started this, the issue that we had is in lesson 14, we learned how to do these types of problems where mu is 0 and sigma is 1. Here in lesson 15, we're going to be doing these types of problems where mu could be any value, because remember, there are infinitely many normal distributions. There's lots of things that are normally distributed. But in order for us to do anything with all those normal distributions, we are going to have to convert them to standard distributions, because it is down here that we know how to calculate these probabilities using either the table, the calculator, or StatCrunch. So that's what we will be working on, is converting these x scores to z scores and then going in and finding those probabilities.